We can also create filter based on regular expression. So in case the request contains dangerous string, the filter will block it and requests will never reach the actual backend method. This method is also commonly known as sanitized input. For example, let's create new SQL injection filter. On build.gradle, add dependency to comments.io. We will need it later. Now, create a new class under package api.filter. Name it SQL injection filter. Annotate this class as component. To create the filter, we can extend class once per request filter provided by Spring Boot. At this point, you will meet compile error. Click on the vertical bar and choose Quick Fix by Add Unimplemented Methods. The filter will check whether API request contains dangerous string using regular expression. When there is any matching regular expression pattern, filter will block the request. So we need to specify the dangerous regular expression. This regular expression is just sample regular expression for simplicity. It will block select from and drop statement. For more complete regular expression, you can see resource and reference section at the last section of the course. We need to build regex pattern from this array to validate SQL. In the class constructor, build the validation pattern list from specified regex. We will need to validate whether a string contains dangerous regular expression. To do this, create method isSQL injection safe which takes string to be validated. Inside the method, we will check the string. In case this is an empty string, then it means the string is safe. Otherwise, we will check the string against all regular expression in list. If there is any matching regular expression pattern, means this string is dangerous. When no matching regular expression, the string is safe. Now, we need to implement the doFilter method. Take all the string to be validated from query parameter, request URL, and request body. We need to handle possibility of parameter is not accessed. I will use Java optional for checking existence. First, get the query string. At this point, I use URL decoder. Later on, we will learn more detail about decode. Simply said, it is used to parse input string from certain format. In this case, from URL. Then, path variable. And then the request body. In here, remove all line breaks for regex validation. Then we will check each of the string for SQL injection. In case all strings are safe, we will process the request. Otherwise, we will block the request. In this case, sending bad HTTP status code and some simple message. Please note that we built only basic filter for simplicity. In real world, you might need to fine-tune the filter. For example, filtering only certain endpoints or tuning the regular expression. Now, let's try it on Postman. Start the application. Send some of the dangerous script on endpoint get by email and get by gender. We can use any endpoint from JDBC subfolders. I will choose the sample dangerous script which has word select from and drop. And the filter will reject them, giving error message and bad request status code. Now, try to create a new data using the endpoint. Bad request will be rejected. Now, use a good data. At this point, you will encounter error. GetReader has already been called for this request. This has nothing to do with SQL injection, but more of Java HTTP flow, where GetReader method can only call once. Behind the screen, this method will be used by Spring to read request body. We already called the getReader method once on filter, so the request body cannot call it again. To fix it, I provide two custom class to catch the request body so it can be used multiple times. Copy-paste the class from lecture, resource and reference at the last section of the course. The classes are onPackage API.filter with name, catch body HTTP servlet request and catch body servlet input stream. Now, go back to filter, and instead of using HTTP servlet request, we will use catch body HTTP servlet request. So adjust the code. Use the catch HTTP request in all usage. Now, try to create endpoint. And we will get the data. It is also a good idea to validate your input to prevent SQL injection. For example, in this simple version of filter, we still allow SQL scripts like delete from or create table. We will validate the input on gender code, so it contains only valid value, capital N or capital F. Head back to build.gradle and add dependency to Spring Boot validation. Now, go to JDBC customer. We will validate the field for gender code and email. The gender code will receive only capital M or capital F. And the email must be in valid format. For this, we can use email annotation provided by Java. Then, in the edge of the API class, add validated annotation. Add method that requires class JDBC customer, add a valid annotation on request body. Start the application. The validation happens when Spring tries to convert string to Java class. So in the example, it will occur only on create endpoint. Try it. Put some invalid email on the new customer. And it will be rejected. Also, when you put invalid gender code, it will be rejected. We can also add validation on the query string or path variable. For example, adding this pattern validation on gender code as query string. Now, if we put any other string other than capital M or capital F when finding customers, it will be rejected. For example, when trying to use this, or even as simple as change M to invalid character. Spring provides many annotations for validating input, not just regular expression or email. You can use more of them, like validating that input string contains character, not only white space or blank. Validate string length or collection number of elements, and many more. Refer to last section of the course, lecture, resource and reference for more annotation.